Namaste friends. In today's final punch KCET 2020 hydrogen chapter I am going to discuss from first PUC synopsis part. From this chapter very less number of questions we have seen, but you should not leave this chapter. Whatever synopsis I will tell you in 4 to 5 pages, you read once or twice before the exam, that is enough. You can solve any question of the hydrogen chapter. So don't leave this particular chapter. Remember, at least 1 marks if you get it also, your rank will be more than 200, 300 from the point where you are now. So, hydrogen isotopes first we'll say. Protium, deuterium, tritium. Right? Protium you can say 1 proton, 1 electron, 0 neutron is present. Deuterium, 1 proton, 1 electron and 1 neutron is there. Tritium, radioactive isotope of the hydrogen, 1 proton, 1 electron and 2 neutrons. Remember, 2 neutrons. Remember this, in NEET JEE exam also it was asked which isotope of the hydrogen having 2 neutrons, so which is radioactive. Such type of questions it was asked. Remember this point. Then preparation of hydrogen. Very simple. Remember this flow chart. First one, zinc plus sulfuric acid, so which will liberate hydrogen gas. When water undergo electrolysis, it liberates hydrogen gas. Sodium or potassium with water, highly reactive, so to liberate hydrogen gas. Zinc, magnesium or aluminum react with hot water, liberates hydrogen gas. Iron react with steam to form the hydrogen gas. This process is called as Lane's process. Remember this point, important for NEET, Lane's process. And this one very important. These are all the metals, zinc, aluminum, lead, silicon. So silicon is the non-metal, so but it liberates hydrogen gas when it reacts with sodium hydroxide or potassium hydroxide. These are all the preparation of hydrogen gas. Very important preparation is this one, coal gasification. So remember, so carbon when it reacts with steam, carbon, red hot carbon we call it as red hot carbon, when it reacts with the steam forming water gas, CO plus S2 mixture, water gas. From this water gas, remember, we can increase the yield of hydrogen. We can increase the yield of hydrogen. So from water gas by passing it through the more amount of steam. So in presence of FeCrO for iron chromate or cobalt oxide as a catalyst at 673 Kelvin. Remember this we call it as coal gasification. This we call it as water gas shift reaction. So here what happens here? So water gas when it reacts with some more amount of steam at this Kelvin, CO2 and S2 is going to form. CO2 and S2 is going to form. See here, already S2 is there. It will not react with water now. So this carbon monoxide react with water. It will form CO2 and hydrogen is released. See, 1 molecule of S2 become 2 molecule. In mole if you convert, 1 mole convert into 2 mole. If you consider 50 moles convert into 100 mole. See, yield of hydrogen is increased. So hence we can call it as water gas shift reaction. Very important. This was asked in 2015 or 16. I am not remembering. I will show you that question. So further CO2 is absorbed by alkali, KOH or NaOH. Remember very important thing. See, both are gases. So this can be separated by very easily by reacting it with KOH, because KOH or NaOH, it is good absorber of CO2 to form K2CO3 or Na2CO3. K2CO3 or Na2CO3 it will get converted into. Hence remember CO2 and S2 is formed by using this reaction, that CO2 is separated by reacting it with alkali. Then chemical properties, with lithium or any metal hydrides are possible. With copper oxide, CuO it is. Cu plus H2O, H2 plus Br to 2HBr, 3H2 plus NH2, Haber's process NH3, we know that. Then very important point is hydrogen is used to react. Hydrogen is highly reactive. Remember, highly reactive. Hence, transport and storage is very difficult for hydrogen. Hydrogen is highly inflammable also. Remember. So, it can catches fire very easily, highly reactive. Then hydrides. See, hydrides, binary compounds of hydrogen with metals. So, types of hydrides you remember, ionic hydrides formed by alkali and alkaline earth metals, group 1 and group 2, except beryllium and magnesium, which form covalent hydride. Beryllium and magnesium form covalent hydride. Side. Right. Salt-like or saline hydrides. It is salt-like or saline hydrides. In water, it will have hydrogen gas. Very important reaction. Remember, hydrides, ionic hydrides in water releases hydrogen gas. These are having high melting point and boiling point and highly reactive, just like ionic compounds. Remember, highly reactive, high melting and boiling point. Covalent hydride. Very important, these three classification, remember that. So first one, electron deficient hydrides. See, covalent hydrides are, first of all, it is formed by p block element. Formed by p block elements. Remember, this is formed by s block elements. S block elements. This is s block element and this is p block element. In this electron deficient hydride, formed by group 13. Electron deficient because remember, surrounding the central element there is no octet. 8 electrons are not there. 3 hydrogen means 3 bond. 3 bond means 6 electrons are there. Hence they are electron deficient. Always electron deficient can act as Lewis acids. Remember that. Electron precise hydrides. Electron precise hydrides formed by group 14. So CH4, SiH4, etc. Electron rich hydrides. See, electron precise because there is no unpaired electron. There is no lone pair of electron. And there is no incomplete octet. This is completely octet arrangement. Hence it is electron precise. Then electron rich. Electron rich hydrides are formed by group 15, 16, 17. 18 does not form. That is noble gases. So NS3 for example, PH3, H2O, HF, HCl, these are all example for electron rich hydrides and act as Lewis base. Base because there is a lone pair of electron present on this nitrogen, this phosphorus, water, like that. So electron rich hydrides. Then metallic or interstitial hydrides. Remember, metallic or interstitial hydrides formed by D block transition elements and F block elements. So these are all non-stoichiometric hydrides, which means there is no particular ratio like NH3, SCH4 like that. So non-stoichiometric hydrides, very, very important. Hydride gap, the word you will see in the periodic table. Hydride gap means this group number 7, 8, 9 does not form any hydrides. Hence it is called as hydride gap in the periodic table. In group 6, only chromium forms hydride. Remember that point also. Then we will see water. About water, already we know that. Preparation properties I am not going to explain. So hydrogen bonding is present in the water. High boiling point is 100 degree. One water molecule can form 4 hydrogen bond. Remember that. Water has maximum density at 4 degrees Celsius. Remember that also. Because at 4 degrees Celsius, only hydrogen bonds are going to break. Because of that reason, the water molecule come very close to each other. At 4 degrees Celsius, water will have maximum density. And it is universal solvent, which is having high dielectric constant. Very high dielectric constant, hence it is very good universal solvent, we can call it as. Then heavy water. Heavy water is nothing but D2O. So deuterium is present instead of hydrogen. Obtained from prolonged electrolysis of ordinary water. Remember, ordinary water and molar mass boiling, molecular mass boiling point slightly higher than the ordinary water. That is obviously because this is having D, that is having hydrogen. So heavy it is because of the more molecular mass. That is about heavy water. Then remember hard water, soft water. We know that hard water, it is because of the soap does not form lather easily. Soft water which can form lather easily. Hardness, there are 2 types of hardness. Temporary hardness, permanent hardness. Temporary hardness is due to the presence of bicarbonates and calcium and magnesium. Remember, very important. Carbonate, temporary hardness is due to bicarbonates of calcium and magnesium. Permanent hardness is due to chlorides, sulfates, nitrates also you can take of calcium and magnesium. Very important differences. They can ask, remember, temporary hardness is due to bicarbonate of calcium and magnesium. Permanent hardness is due to chlorides, sulfites of calcium and magnesium. Then removal of temporary hardness. So removal of temporary hardness, 2 methods you remember. One is boiling, second one is Clark's method. So in the case of the Clark's method, you remember this CaOH twice, slaked lime. It is not lime water. In P block element, I have clearly explained what is slaked lime, what is milk of lime, what is lime water, clearly. So see that if you have not seen that video, right? Clark's method. So slaked lime is used. So what happens when slaked lime is used? For example, say this is calcium and magnesium bicarbonate hardness, correct? So magnesium bicarbonate is present in the water. Just imagine. Reacts with calcium hydroxide forming MgCO3, CaCO3 plus H2O. So that these two are precipitate, get settled down so that water which can filter, so that we are going to get a soft water. So boiling and Clark's method is the best method. And removal of permanent hardness, it needs some chemicals. Permanent hardness is removed by sodium carbonate, which is the good component present in the dishwash, that is these detergents, remember, detergent. Hence, these detergents will give lather very easily in the water because the sodium carbonate component will be there that will remove the permanent hardness of the water. To remove permanent hardness, we can use zeolites, ion exchangers which can be used. Ion exchangers which can exchange these calcium and magnesium ions from the water. Another important Kalgan's process. So Kalgan's, remember, Na6P6O18, sodium hexametaphosphate. In this case, this sodium will replace, say, calcium or magnesium from the hard water, so that water get purified, water get softened, remember. So Kalgan's, the formula and the chemical name, you remember, Na6P6O18, sodium hexametaphosphate. Then hydrogen peroxide. Hydrogen peroxide, remember, open book like structure. Open book like structure, so like this, and boiling point is higher than the water due to stronger intermolecular hydrogen bond. Important. It is having more boiling point than the normal water. The reason for that is stronger intermolecular hydrogen bonding. Then preparation, very simple. Preparation. So Na2O2, sodium peroxide in water, hydrogen peroxide. Sodium peroxide in 20% sulfuric acid, hydrogen peroxide. Barium peroxide with carbon dioxide and water, hydrogen peroxide. Barium peroxide with sulfuric acid, hydrogen peroxide. Which means one thing, it is very clear. Hydrogen peroxide is prepared from sodium or barium peroxides only. See, in case of the alkali metal, only sodium from sodium peroxide. So barium and strontium, barium or strontium both can form peroxide. So barium or strontium you can use. Barium you have used it here. And another preparation, ammonium sulfate, when it reacts with sulfuric acid forming ammonium bisulfate. This ammonium bisulfate, when it undergo electrolysis, remember, ammonium bisulfate undergo electrolysis, you are going to get peroxosulfuric sulfate, S2O8 minus, ammonium peroxosulfate. This peroxosulfate, which is having peroxide linkage, reacts with water. On hydrolysis, you can call it as, you are going to get H2O2 and ammonium bisulfate. See, not necessary to remember these reactions, but ishtu talelirli. You have to keep it in mind. Sodium peroxide, barium peroxide give rise to hydrogen peroxide. Similarly, ammonium sulfate with H2SO4 electrolysis give rise to H2O2 by followed by hydrolysis. This one. So, in this particular case, so when it undergo oxidation, remember, you are going to get hydrogen peroxide. So, this is in this particular case. Remember, H2O2 act as both oxidizing as well as reducing agent. That is very, very important point in this particular case. Because H2O2 can undergo reduction also and oxidation also. H2SO4 can undergo reduction also and oxidation also. Because of that reason, remember, it can undergo both oxidation as well as oxidizing agent as well as reducing agent. So, in this particular case, and this name I have not written, 2-ethyl anthraquinol, 2-ethyl anthraquinol, THRA2-quinol, 2-ethyl anthraquinol. So 2-ethyl anthraquinone is going to form, H2O2 is removed. H2O2 act as both oxidizing as well as reducing agent. So remember how it will take place. See, when H2O2 undergo decomposition to form water and O2. See this reaction, very, very important, remember. So carefully you have to say H2O2 which undergoing formation of water and oxygen gas. Correct? So when it forming H2O, -1 to -2 oxidation state of oxygen. When it forming O2, -1 to 0. Which means this reaction is called as, remember, disproportionation reaction. Disproportionation reaction. Because same element undergoing both oxidation as well as reduction. One thing I will tell you, always oxidizing agent is the one which can undergo reduction itself. Correct? So it acts as oxidizing agent. Remember, byproduct will be H2O. Fix this point. Listen once again. When H2O2 act as oxidizing agent, byproduct will be H2O. When H2O2 act as reducing agent, byproduct will be oxygen gas. Very important. How to identify when the reactions are given. So whether in which case H2O2 act as oxidizing agent, reducing agent, such questions can be asked in the exam. In such case, you have to see the byproduct. So H2O2 acting as oxidizing agent, undergo reduction itself, H2O is the byproduct. H2O2 acting as a reducing agent, undergo oxidation itself, oxygen gas is the byproduct. Remember that point. Then some more important point. H2SO4 undergo decomposition very easily. Remember, cannot be stored in glass bottles because of that reason. Hence, glass catalyzes, because the reason is glass catalyzes decomposition of H2O2. It will increase the decomposition of H2O2. Instead of that, you can store it in colored paraffin wax coated bottles or plastic or Teflon bottles. Remember, H2O2 cannot be stored in glass, but you can store it in colored paraffin wax coated glass bottles or plastic or Teflon bottles. Urea prevents the decomposition of H2O2. Very important point. Remember, urea, which can act as a negative catalyst, which can prevent the decomposition of H2O2. Remember, H2O2 is weakly acidic in nature, but stronger than H2O. Acidic nature of the H2O2 is stronger than H2O and weakly acidic compared to other substances. And used as anti-chlor. Anti-chlor antandre, instead of chlorine, you can use this. Instead of chlorine. It is also act as a bleaching agent. Remember, bleaching agent. But chlorine, when you use, remember, it leads to the atmospheric pollution. But H2O2, byproducts are either H2 or O2. Hence, remember, it is eco-friendly. Used as antiseptic, remember, oxidant in rocket fuel. Antiseptic, oxidant in rocket fuel. Finally, this part. So, reactions of H2O2. And once again, I will tell you, no reactions has to be remembered. What you have to remember is, when it acts as reducing agent, when it acts as oxidizing agent, how this reaction take place. But generally they will not ask any reactions of this type. See, reducing agent means Ag2O plus 1 reduced to 0. Hence, this is acting as a reducing agent. What is the byproduct? Ag plus, what is the byproduct I told? When it acts as a reducing agent, product is oxidized product O2. Remember that. Product is oxidized product O2. When it acts as oxidizing agent, product is water. So, byproduct is water. It will undergo reduction itself. So, Cl2 give rise to Cl, HCl, KMnO4 give rise to MnSO4, potassium dichromate, Cr2SO4 thrice, ozone give rise to S2O, and PbO2 give rise to PbO. Similarly, here PbS give rise to PbSO4, Ki give rise to I2, HCHO give rise to HCOH, benzene give rise to phenol. These are all the reaction of H2O2. Don't worry about these reaction. Exam only question keldaga, so you can easily identify the product. Because it acting as reducing agent, oxidizing agent. So oxidation number should increase in all this case. It should decrease in all this case. Increase in all this case, oxidation, and it should decrease in all this case. So you can easily identify. Then strength of H2O2. So numericals are not there for the CET exams, remember. So hence I have not taken. So that will be solved in NEET and JEE. Strength of H2O2 is explained in volume strength. Important. If you take any bottle of this hydrogen peroxide, you can see on the bottle, so 10 volume, 20 volume, like that. Then what is the meaning of that? See, X volume H2O2 means 1 ml of H2O2, NTP, normal temperature and pressure, gives X ml of O2. Remember, volume strength of H2O2 is based on the amount of oxygen which it can release. So, 1 X volume of H2O2 means 1 ml of H2O2 at NTP gives X ml of O2. 1 ml it is. This X you have to take it here. See, 10 volume H2O2 means what? 1 ml of H2O2 gives 10 ml of O2 at NTP. See, X volume 1 ml gives X ml. Here 10 volume 1 ml gives 10 ml of O2 at NTP. Very important point. Then we will see previous year questions. Very simple question. So 2019 asked question. Which of the following is not true regarding usage of hydrogen as a fuel? See. High calorific value, definitely calorific value will indicate the strength of the fuel. Remember that. So high calorific value, definitely it will be there. Fuel means it should be there. The combustive energy of the hydrogen can be directly converted into electric energy in a fuel cell. Electrochemistry chapter, you remember. In case of the fuel cell, remember. So combustion energy hydrogen can be directly converted into electric energy. That is also correct. Combustion is eco-friendly, definitely. But hydrogen gas can easily stored, they are telling. So definitely answer is D. You cannot store hydrogen easily and transport easily or liquefied easily. The reason for that is it is highly reactive. So remember that. Which of the following is a ion causes hardness in water? Very simple question. Hardness in water is because of only calcium or magnesium. Only calcium or magnesium. Remember, answer is A. H2O2. H2O2 is an very simple question. 2018. See, 2019 one question, 2018 two question. Next I will show you no question. So remember, H2O2 oxidizing agent, reducing agent, both oxidizing, reducing, neither oxidizing, reducing. So even if you listen these carefully, even a small child can tell the answer for this question. Remember, why not you? Definitely C is the answer, both oxidizing and reducing agent. Here, in the manufacture of hydrogen from water, 2017, which of the following is correct statement? Correct statement you see. In the manufacture of hydrogen, I told CO oxidized to CO2 with steam in presence of water gas is nothing but CO plus H2. In that CO plus H2, CO is oxidized to CO2 with steam in presence of catalyst followed by absorption of CO2 in alkali. So this statement you can see. I told that important. It is asked in the exam. See, further CO2 is removed by absorbing it with alkali. Very important point. Water gas shift reaction. Don't forget. So CO is oxidized to CO2 with steam. This is the correct answer actually. H2 is removed by occlusion is wrong. Hydrogen is isolated diffusion wrong. COH2 are separated based on difference in their density is also wrong. So the correct answer is A. Remember that. Then H2O2 cannot oxidize. H2O2 cannot oxidize. Remember. Which one? C. This can be oxidized. This can be oxidized. This can be oxidized. But O3 is reduced. O3 is reduced. Remember. Because H2O2, when it reacts with O3, forming O2 plus H2O. O2 plus H2O. In both the case, remember, oxidation state, here it is 0, but here it is -2, which means O3 reduced to -2, O3 0, reduced to -2. So, it will never be oxidized. So, the answer for this question is O3. Last one, water softening by Clark's process uses. Class method, slaked line. Slaked line formula is which one? Calcium hydroxide. So, the answer is calcium hydroxide. Very simple. 2015 asked question. See, 2015 2 question, 2016 no question, 2017 1 question, 18 2 question, 19 1 question. Hag nodidre, this is important than the redox reaction chapter. Remember, important than the redox reaction chapter. So, I hope you understood this. So, don't worry about this chapter. Question, if it is less also, don't leave this chapter. At least you read whatever the synopsis I have covered in 4 to 5 pages in this case. So very easily you can crack any type of question on this chapter. If you want this colorful notes, remember in the description box I have given Telegram link. So click on that so that you are going to get all these colorful notes in your mobile. Yes, if you are first time visitor to my channel, subscribe to my channel and share to your friends to the maximum so that they should also get some use from this. Thank you. Have a nice day.